and we're going to record it so that if the live isn't working, because when I go back to the live thing, it's not saying it's live. So I think we're just going to have to record it and put it on.
Okay.
So go ahead, and I don't know why it's not doing it. So
are we recording?
We are recording. I will go for another live. We are recording. But go ahead. Go ahead with what you're doing, because we are recording.
Okay, so this is my challenge yesterday, was to go find 3 circles of the same size and put them together and tell me what the shape is that you've created. So this is my one. I couldn't find any more biscuit tins, and I've eaten all the biscuits. But let's imagine that we've got 3 of these. So we've got 1, and we've got 2, and this is just playing with shapes and finding out that shapes create beautiful patterns, but very often geometric or pretty or mathematical. So that's about as close as I can get. They're all touching, that's slightly overlapping. So, so it's not going to be exact. But we've got a triangle, so they're about as close as you get. I'm going to guess that the centres are there. So if I used a compass, I'd guess it was roughly there. And find a straight line, a little bit of cardboard, and draw a line between the points. There. Oops, there. We've got a triangle, but we know that distance from the centre to there is the same as the distance from there to there, so that is twice the radius, which is the diameter. That's got to be the same, and that's got to be the same. All 3 sides are the same, and if everything is equal and it's equal-sided, we call it equilateral, equal-sided, equilateral. So that's an equilateral triangle. So if you push 3 circles together of the same size, you create equilaterals. This is what bees do. We always argue about this. But,
okay.
So, and
that was
if you continue this round, you have another one there, and you continue it round there and up here. Lovely hexagon made out of.
And you can start creating art. And if you Google or go on YouTube and look for Islamic art, there's a lot of resources on there, so you can just do maths and art all at the same time.
And art, and they come together. Maths and art comes together, great beautiful shapes, and very often things that occur in nature. Oh,
so that's yesterday's challenge. And you can just go all over the place with that. You can really extend that and make some amazing get very engaged in the process, and you're also doing draftsmanship, it's all back drawing, it's back drawing accurately, and it can go a lot further with that and just explore it. So that was yesterday's challenge. So what are we covering today? We're going to talk about how to give meaning to numbers. So that's for younger children, also children with special needs, and learning numbers difficulties. And also we're going to do something about a different way of representing numbers. Yes. So which would you want to start with? The giving meaning to, or ways of representing with our point?
Okay, so I had a new student today, and quite quick. And I showed him my numbering system just to ask him what he thought about it. And if you remember it, let's go through it just quickly. 1 and 2. This is the old system, one we have to use every day. Been given, so we have to do a better with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I won't use 10. I'll use 0. So really, I should have put it at this end. Okay, so I think, to me, when I think of 1, I think of just a point. Just a point. Point A, you can call that.
This, by the way, is actually the way Lenny visualizes numbers, which I discovered yesterday, and I think it's. Yeah. And the interesting thing here is you don't know how your child visualizes numbers, and you might not visualize numbers. You won't visualize numbers the same way I visualize numbers.
No.
It's an interesting exploration on discovering how each individual visualizes numbers.
Yeah.
So this we're having an insight here into Lenny's mind.
Don't forget, we only
going.
learn numbers. We learn numbers after we've learned shapes. So, we probably learn patterns before we learn numbers. So numbers come later. I'd be interested to know when kids start counting. I wonder what age they tend to start.
Well, I can tell you, my grandson, I used to, when walking up and down stairs, I would count the steps. Now, I don't know if I don't think he got any actual significance into counting the steps. But when one of the first things he could do when he was talking was count the steps with me. So if I was carrying him up the stairs and I wasn't counting, he would count. Because grandma counted, so it was just what he did.
And
so you can learn. Oh, he was about 18 months when he started doing that.
Oh my gracious. Okay. And I wonder what significance it had.
Well, that I don't know. It probably had the significance of this is the noise that grandma makes when she climbs the stairs.
I think that's what it is.
But I mean, he did start learning how to count, and he clearly loved the pattern.
Yeah, I think we learned a pattern of numbers. I think we learned a pattern of numbers through nursery rhymes and songs and counting songs.
Yeah.
Three blind mice and Baa Black Sheep and things like that. I think that's where we learn the patterns from. Even the songs themselves, this is something we're going to do later on, even they have a pattern, usually 4 bars of 4 and things like that. But anyway, this is how I see numbers, because this is how I saw numbers.
Yeah, I so rudely interrupted you. Go ahead, Lenny.
Okay, so that means 1 to me. I can do that, I can do that. That means 2, so that's point A to B. So 2 points means 2 to my new numbering system. There we go, that is 3. And I let Charlie decide himself what our next shape should be. He said square. Well, I didn't have to ask him. And he came up with square. So he's got, you can see the process, that it's we're just progressing. We're adding another point. We can add a new point. And I just start there. I go down there, up to here, across to there, down to there, and back up there. Got a lovely 5. The 5's pointed star. So it's the simplest, easiest star you can create. It's the first star. Can't create a star with 4 points. You can create a star with 5 points. So that's 5 for me. I didn't think of this. This is something Charlie thought up. He's called 6 a rectangle, which is right. Of course he is, because a rectangle is 2 squares ultimately, or two rectangles put together. So he said 6 is a rectangle, a Lego brick, if you like. So that's 6. I like to do that because we can count where the crosses are, where the points are. And then 7, for me, is the 6 again. But you just create a single point and you put a triangle on top of the 2 blocks. So effectively, 1, 2, 3, 4, 5, 6, and then another one to create 7. So there you have 7 different points. 8 for me, this is 8. 8 is quite simple, it's just 2 of these. So we've got 2 blocks of 4. 9 for me is tic-tac-toe. You just join them like this. I don't know if this is too small or if you can see this. And then 0 for me can't be anything else. You've just got to represent the space. So we've enclosed it within a circle. So 0 is actually 0. I call it 0 sometimes. So there you go. So we've got dot, line, triangle, square, star, rectangle, house, blocks, tic-tac-toe, and 0 or 0. There you go. So,
and it occurs to me, what I would be looking at is I'd be looking at a 7, for example, is instead of combining the 6 and the 7, the 6 and the 1,
yeah.
There's lots of other different ways. Basically, the question you can ask, you can do it as a family even, because this is as much a challenge for me to find all the different ways you can represent different numbers. So, for example, you can combine, the 7 could be a 5 and a 2. So you could do a star and a 2, or a 7 could be a triangle and a square.
Yeah.
and so you can find all the different ways you can create all those different numbers, and it's what it's called number bonding.
Yeah,
that's the technical term. But you're actually finding all the different permutations and combinations, but basically you're looking for effectively a mathematical proof to find all the different ways you can make those numbers, and it doesn't have to be Lenny's way. They can represent the numbers in their own way. And this could be a family activity.
Yeah, it's a family activity. This is just a simple system. If we're talking about, I think we're going to call this session, what do numbers mean? And this ultimately is the answer. What does one mean? One means a lonesome point, all on its own.
And you could get counters. You can represent them with different things, and you can put them on the dots and draw the shapes in between the actual items.
Absolutely,
the actual physical thing that you've got.
You know that's
you could use chocolates.
You can use chocolates. You know that's 2. You can see that's 3. You can see that's 4. Move it down and you create 5. As you draw your star, you can do your rectangle. So it all makes sense. There's your 6. Your 7 you put up here. So it just works. And then your 8 will go over here. And then your 9, quickly move things around. 1, 2, 3. And it all makes sense.
You can get creative, and you can
get creative.
You can get creative, but what I'm thinking, it's just something that's just occurred to me, is you could create art, literally create a drawing of some kind.
You are.
And then, but I mean, you can just literally create a drawing, like a bit of an abstract drawing. And then at the end of it, you can see, well, what are the patterns? Does a person automatically go for patterns? And perhaps if you do go for patterns, then you're going into multiplication and things where perhaps you can say, well, okay, well, we've got several groups of this. How many numbers do we have? What do the total numbers mean on this
so
beautiful
Really,
creative?
that's right. So we're used to doing our decimals. We're used to using the decimals. This is actually a decimal system. It's just used a different way of representing the numbers that we already know. So this could be a code as well. Now, Carly, halfway through the lesson, he suddenly shouted out, all right then, if it's such a good system, what is triangle times square? And I thought, oh my goodness, how would you, I hadn't even thought about how do you use it. And I thought, I just thought for a second, and I thought, well, what he's saying is, what is a triangle of squares? What does it mean?
And that's one way. And then the other way is you'd have one triangle on each dot of the square. So that way.
That's what he's asking me. So he's asking me, what's 3 times 4?
And then do it the other way.
Or what's triangle times square?
Now do it the other way. Draw the square and put the 4 triangles
do that?
on.
Let's try that.
Yeah, please.
So that'll work.
And then do the other one.
So let's do the other way. So
with the
3 times 4. 3 times 4 equals, well, if you cancel all this up, we'll end up with 12. Let's try the other way then.
Yeah.
Let's try that and see if that
I'm like, I don't want to draw on the board.
You want to draw, you want to
which reminds me, grown-ups, parents, don't be doofers. It's allow the children to explore for themselves, like I'm allowing Lenny to explore for himself. I can't grab the pen and take over. Really, do not take over and do it for them. Allow them to explore and allow them to make mistakes. And instead of saying no, say keep on thinking. Use things like that. Ask questions. And if you don't know the answer, by the way, it's okay if you get the answer to the question if you don't know the answer. What the answer is, let's find out. And they can see you modeling how to do it. And if you are struggling, just send us a message on the group and say, how do I do this? I've been asked this question. I don't know how to do it. And we can give you some guidance on how to do that.
We use the magic word, which is modeling. That's ultimately what we're doing. We're manipulating shapes. And which is what we're doing when we're doing calculations. We're just
all right. But I still haven't seen my 4 triangles making a square.
So you're happy with that?
No, don't rub it out. Do the other one.
I'll leave it out, and I'll do our.
I'm being a doofer. I'm telling you what to do.
4 times 3. We know that 4 is our square. and we know that 3 is our triangle. So what we can do, I think is what you're saying, is we can put 4 triangles, 1, 2, 3, and 4. So what is square times triangle? Square. So we've got a square of, and let's put points on here so we can count them. So this is we're doing a triangle times table, and the triangle times table is 3, 6, 9, 12. You can count them if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer to square times triangle is 12. And the answer to triangle times square is 12.
As you can see, you can get creative. You don't. It never even occurred to me to even think of numbers this way. And look, this is all coming out of the way Lenny visualizes numbers. So you can allow your own child to represent numbers in a way that is meaningful to them.
Yeah.
And create art with it.
Well, one thing I know.
Play with it.
One thing I know is we've got a shortage of engineers in this country.
Yeah.
The Germans value their engineers because ultimately making things, complicating things that work for a long time helps towards the economy. And we've got fewer engineers than we like. We've got very creative people, but we haven't got enough technical people. And this is how you start. This is how you build your engineers. You build it from this idea that putting shapes together creates amazing things. You start. We had a little chat about Minecraft, and I'm sure you know what Minecraft is. Minecraft is it's a video game or an online game, and you just put blocks on top of each other to create buildings. And they're square. They're always cubes, but you can have different sized cubes. So with different sized cubes, you can create any shape you like. And I only found out 2 days ago that in Minecraft, with these square blocks you put on top of each other, they've actually created the whole of the earth, the whole of the world in Minecraft. In these cubular blocks, they've managed to get one modification that uses the blocks. They've mapped it onto Google. They've somehow put the 2 together, and they've created the whole of the earth in cubic blocks, which is kind of amazing.
Where do I see that? How do I see that? What is that?
I Googled the earth in Minecraft. So,
yeah, I can't put anything on here. So when the live isn't working, so we're going to just put this on. Can we put that on there? Oh my goodness, I'm going to write no, make a note. We're not going to have time to do the other thing, whatever we were going to do, or if we no, that's right, the 10 times, because this is literally we're recording this, so we're going to have to stop at after half an hour.
Lovely. Okay. Well, I'm happy with that. If you're happy with that.
Yeah. So, but I must make a note of that. So, what Google what?
It'll be the
world with Minecraft or something.
The world with Minecraft, or it'll be the Earth in Minecraft.
Oh, that's fantastic.
I heard about it from somebody else, and it's So I think if you just we'll have to say Google. If you just browse on your preferred browser and just put in Minecraft and then put in the Earth, maybe put in map. It's a lovely video. I think it's about 10 minutes long, and shows you how they recreated Everest, Mount Everest, and Machu Picchu. And they need other engineers. They call them engineers to put in the buildings into this world. So that's an invitation to Minecraft. And it's a collaborative affair.
I'm telling my stepson about that. He's going to love that.
So if you've got an engineering bent, that's somewhere to go. So I've never played it, but I'm still fascinated by it.
I'd like. Oh, Minecraft is pretty amazing. Although I only like the creative. I don't like the other one where you can die and you have to kill things. I like the creative where you're just constructing and building and being an engineer. Yeah.
And this is me getting them early, get them young, and say, look, if you can understand squares and triangles and stars and everything like that, you can create anything you like.
And I'd like to add
Mm.
Notice how I was holding back there. I'd like to add that girls too, please. I'm an engineer,
Oh, absolutely.
And encourage girls. Now, girls might want to play more feminine type games, but that doesn't mean they're not going to want to construct. So please do encourage girls to play these games as well, and let them get hooked on being engineers.
Yeah,
because we're a completely different kind of engineer to the blokes. Blokes
I think so.
I can be pretty practical, but we're just different. And together, you get a team of male and female engineers together. You create more magic than if it's all women or all men. So
isn't there a great film about the woman who nobody knew helped create the nuclear bomb or created nuclear fission? So it's only
I haven't seen that one. Crikey.
The last 2 years, and it was an African American woman, and she unsung hero. And it's only recently that I found out how important she was to the. I think she had a lot.
There was the women with the Apollo.
That might have been it, actually. Yeah, it might have.
They called the women calculators.
They called them calculators.
An African American woman that was
that's probably the story I'm trying to tell. Yeah. So,
although similar, well, no, it was before. It was during the Second World War for the atomic. I don't know how many women were involved in that behind the scenes. I know that at not Bexley Park. What's it called? Bletchley Park. There were a lot of women working there, women mathematicians.
It would have worked out
again. You only hear about the men. So the women are so.
Absolutely.
So encourage the women to do it. So we're going to leave it there because this is being recorded and we don't want it's not live. So unfortunately.
All right. Shall we set another challenge?
Okay. Yes. Set us a challenge.
Okay. So you can see what 3 times 4 is, or triangle times square. So why don't I give you another one to work on using my system? And shall we say what is? Oh. Try a pen that works. What is star times? Let's call it.
Got an invisible marker.
Yeah.
Modern technology.
That's it. That's because it's still wet. There we go. That's better. So star times rectangle. Star times rectangle.
Okay.
What's the answer?
I just went and did lives, and I did live twice, and I did live 3 times, and it just stopped doing live. It just went from being live to stopping being live. Sorry, my tech support has just appeared, and it's not live. We're recording, so that's fine. So the challenge is, what is star times rectangle? And rectangle has how many points?
This has 1, 2, 3, 4, 5, 6.
Excellent. So what is that? That is the challenge. Brilliant.
What's the answer?
Right. So we'll see you tomorrow night. Thank you so much, Lenny, for joining us. We'll see you tomorrow night, every night at 8 o'clock on Making Maths Fun for Kids of All Ages. Thank you. And the resource that we always recommend is the Aiming High resource, which will be in the comments when we finally post this. Thank you for staying. Thank you for watching this pre-recorded live.
Okay, I'll find that Minecraft link for you. We'll stick that straight on.
Brilliant. Thank you so much.
Thank you.
Have a good evening, everybody.
Have fun. Hug a number.
Hug a number. Love it. Bye.
Bye.
Oh, hold on. Sorry, I'm just going to stop recording.